Hello, everyone. Welcome back to the programming demos for cybersecurity fundamentals. In this video, we are going to be discussing about how to implement a mock password storage program, okay, that is implemented in Python. So overall, I will go over the various concepts that is involved in this program. So that would involve understanding the logic of the program and how the program will be implemented, and thereafter discussing about the different programming constructs that are involved and some of the cybersecurity logic that you need to be aware of for you to be able to successfully implement this program and understand the different concepts that are implemented through this program. Okay, so to go over the problem statement first, we will be developing a mock digital password authentication program, and we will implement that using the Python programming language. The prerequisite to be able to implement this program is an external library that we will be using, which is known as bcrypt. Okay, it's an external Python library, and it helps us implement the concept of a slow hash function that is necessary whenever we are trying to develop a digital password authentication system. Okay, so to go over the basics of what a digital password authentication logic involves, the first thing is there is a prerequisite before you can perform any sort of authentication is that the user should already be registered with your system, right? So that is something that we have to ensure that has happened before we can perform any kind of authentication. So when the user does provide their username and password, what we first do is we choose a slow hash function. So in our case, this slow hash function is going to be this bcrypt library. So we will install this library first associated with our program, and then we will use the methods and the properties that are available within this bcrypt library in order to perform this particular operation. Okay, so when we do this user registration, what we do essentially is we take the plain text password that is provided by the user, and of course the user ID that is given by the user, and then we take the password, and then using the library, we generate a pseudo-random or random value, okay, which is known as the salt, and both of these are given as an input to the hash function, and then in a separate storage file, and this storage could be in the form of a file, it could be in the form of an entry within your database that is responsible for keeping information regarding your user authentication details and stuff like that. We will store the user ID itself. We will store the salt that has been generated when the user registration was taking place. And we will essentially store the hash value of the plain text password in that particular file. Okay. So this is basically the process of registration. So once the registration has taken place, whenever we have to authenticate that, again, the user input will involve giving the user ID and the plain text password. So we will take that user ID, we will go to the password file, find the particular user ID that we are looking for, if it is present in the file, grab the salt that was generated when the user was registering with the particular system, and then create a hash again using this process, using the same slow hash function of the password that was given as a input during the authentication process. And that will generate an overall password, so a hash, right? And that hash password will be compared against the hash of the password that was already stored in the password file. And if these two hashes match, then we know that we have successfully authenticated the user. And if the hash doesn't match, then essentially the authentication has failed, and you will provide the necessary feedback. So to go over the program logic on how we will be implementing these two flowcharts within our Python program, let us first assume that the interaction is going to take place between two entities. One is going to be the user, and the other is going to be our program itself. So in the first step, the user is going to connect with the program, right? So that involves running the program itself, Or if you're developing, let's say, some sort of a web application, like an e-commerce website or something along those lines, then the user is basically entering the custom URL and then connecting to that particular web interface, which allows it to access the different functionalities of the program. So once the user connects with the program, the program is going to first provide it with a menu, a mock menu, right? And the menu will have three different options. The first is to register with the system. So that registration process is basically this step where the user is going to provide their username, their password, and it will go through a hash function. And then we will essentially store that information in a password file by separating it in three different columns. One is for the user ID, one is for the salt, and one is for the hash code itself, right? So that is basically the operation for registration. They can also choose the option of authentication and login. But again, before the user can perform this, you have to make sure that the user is currently registered, or at least the user has to make sure that they are currently registered. Otherwise, this will not perform in the way that you expect it to perform, right? And then the third option will be to exit the program. So the user will choose one of these three menus essentially in order to interact with our program. So what can happen after this is that the user can give an input of 1 in order to choose this particular functionality. The user can give the option of 2 in order to execute this particular functionality, or the user can give the option 3, and that will terminate the connection that has been established with the program essentially. So that is basically how the user can interact in the next steps by giving either 1, 2, or 3 as an input to the program. So once the program receives that desired input, so let us assume that if the user input is 1, then the program is going to ask the user for their username and password input, right? So this is an input that will be provided by the user. So the program will be prompting the user to provide the username and password inputs, essentially, right? So then the user will provide the requested input, and they will provide that to the program. Once the requested input is received by the program, what the program is going to do is it will perform the logic that we discussed here. So it will generate some random salt. It will take the plain text password, run it through the slow hash function, which is implemented through our bcrypt library, and then it will store that information in some sort of an internal storage. So that internal storage could be in the form of, let's say, a text file. If you're thinking in terms of a more scaled operation, then it could be within some sort of a database table, right? And the program will store the username, the hash, the salt, and that's it, right? So that's the end of the operation. And then it will return back to the operation where it will again give the user the original menu that we will create, where the user will see these three different options, and then again the user will repeat the interactions with the program until they exit the program, right? So the next thing could be that instead of giving the option 1, the user might choose option 2, right? So if the user chooses option 2, then that means that we need to execute the functionality where we will be authenticating the user input. So once the choice of 2 is given by the user in this particular interaction, then the program is going to request again for the same set of input, because the nature of the input requested for registration versus authentication is still the same at the end of the day. You still have username and password as the primary inputs, right? So even if the second option is selected, which is basically to authenticate a user, then the program is still going to request the user to provide the already registered, or at least the expectation is that the username is already registered, username and password for the input. Once that is received, that is once the user provides the requested input, then the program is going to execute this particular step where it will first check if the user ID is already present in the file where we stored all the registration information. If it is present, then it will take the salt that was generated during the registration, and it will take the input that is given by the user, which is basically the password, run it again through the bcrypt hash function, and then it will generate some sort of a hash value. And then we will compare that hash value with the hash value that we had stored in our password file during the process of user registration, right? So that will essentially give the idea that or it will allow the program to verify or authenticate that particular operation or that particular user's input, right? By comparing the computed hash against the stored hash, right? And then based on whatever the outcome of this comparison operation is, the program is going to return success or failure or incorrect username, which could be one of the three different outcomes of the after the user provides a particular input and the function logic is implemented here. And of course, after the prompt is provided, then it will revert back to the original state of the program, which is the very first state where user will be shown the main menu again, right? So the last interaction that the user can do with the main menu is to specify option 3 as an input. So if the user gives option 3, then all we are going to do is we are going to terminate the connection. This connection that you see here with the arrows between the user and the program, that will be terminated, and then that will be basically the end of the program. So what do we have in terms of the basic programming constructs that are used in this program? So first and foremost, in addition to the different things that we had already learned in the previous demo program, remember the first video of this series was to implement the Visionaries cipher, right? And there we talked about some of the basic programming constructs that was used in this program. So we have those involved here as well. So that is in the form of writing our entire code in a modular way by using functions, Python functions. And of course, we talked about how to print or give or prompt output to the users, right? And this was done using the print statements in functions in Python. So we already saw these different things. We also saw how if-else statements work in the previous program as well for decision-making purposes. So that means if you have a condition, logical condition, and when we say logical condition, what we mean is that if you evaluate the condition, then that condition is basically going to output true or false. And if it is true, then you execute some lines of code. If it is false, then you execute some other lines of code based on the output of that condition evaluation, right? So those are basically if-else statements, and it is very helpful in terms of implementing any logic that requires a branching decision implementation, right? So it's like based on the condition, you are going to run a specific set of code. If the condition evaluates to true, and if the condition evaluates to false, you are going to implement a separate set of logic in your program. In addition to that, here in this particular program, what we learned from the previous basic programming constructs, we also need to get user input. So that means in Python here, when we are saying that the user is going to give, let's say, one of these menu options as input, or the user is going to give the input of their username and password, right? So that requires us to have an understanding on how to implement the logic of getting user input in Python, right? And just like we had learned, when we want to give an output to the user, when we want to prompt the user with some sort of an information, we use the inbuilt function in Python for print, right? And inside of this, we kind of set up our message that will be shown to the user. So similar to that, if we want input from the user in Python, we use the inbuilt function called input, right? And here we give the prompt where we can say something along the lines of enter your password, something along these lines, right? And then we can assign that to, let's say, a variable. So that means whatever the user is going to type in the terminal, right, or whatever user interface that you have created, which is supported by this functionality, that value will be stored in this particular variable. And then going forward, we can use the value inside this variable for, upcoming processings and stuff like that. Okay. The other new thing is basically a while. Now, in the previous program, if you haven't seen that video, then you should check that out. We had discussed about for loops, right? So for loops, essentially the idea behind for loops is that we have prior knowledge with respect to how many times do we want to run a particular program, right? So what I mean by that is, just to give you a quick idea, is like, let's say if you have a problem that you want to implement in programming, which says that print a certain number 10 times by incrementing it by 1 in every step, right? So here, what we're looking at, that this is a repeating operation, right? So we are basically printing a certain number. So let's say that certain number is given as an input by the user, and we want to repeat what operation? The operation of printing it 10 times. So this is the prior knowledge part that I'm talking about, that we have some prior knowledge that this is the number of times that I have to repeat a certain task, right? And that certain task in this particular example will be to print a certain number. And the logic inside that print is supplemented by this particular statement that we want to increment it by 1 units every time we perform this operation. So that means we have to perform a certain operation. It is supported by a logic which needs to be executed in every step of that repeating of process, and that repetitions will occur for 10 times. So if you know something like this already, that how many times you have to repeat it, right? Or you can say another similar situation would be that, let's say if you have a list of length or size 10, right? And then you are asked, the problem that you have is basically print all the values in the list. Okay. So if that is the problem, then we know that the size of the list is basically 10 or 20 or whatever, right? And then we have to print all the values. So that is a repeating operation, because every time we visit one of the indexes of this particular list that goes from 0 to 9, then every time we visit a particular index, then we will have to print those values, right? So similarly here as well. So the logic here, if that is the situation, you can basically use a for loop, right? You can create a loop control variable, which will keep a track of how many times you have already performed the repetition, right? And that loop control variable will be assigned to the starting index, and then it will go till the very last index. And as you visit each of these index, inside of the body of the for loop is where you will write the logic, right? So here the logic is basically print after adding 1 to the variable, right? So essentially, if the value of the variable, let's say, starts at 5, then after the first repetition, the output will be 6, then 7, then 8, and this will continue until you have performed this operation 10 times. Okay. However, if there is also situations where you have to repeat certain tasks and you do not have a prior knowledge of how many times that you have to repeat that particular task, right? So here, for example, in this particular program logic where we said that the user is going to be provided with a menu, and until and unless the user chooses this particular menu option, the program connection will not be terminated. So that means after you perform every set of functionality that the user chooses, so let's say 1 or 2, so you will continue to repeat this process. That is, you will continue to provide the menu after the execution of any sub functionality, and the sub functionalities is, let's say, registration or authentication, right? And then it will continue to do so until the user clicks or chooses this particular option. So if we want to write this as a problem, okay, that we want to code, then it will be something along the lines of sustain the connection with the program. So here we can say sustain the user connection with the program until the user selects option 3, something like this. So another problem that you can think of is continue to print the values in a list until the value 0 is printed or the length of the list is reached. Max length of the list is reached. Right. So this is a little bit of a tricky situation, but the main thing that you have to understand here is this word which says until. Right. If you have a logic like this, where essentially we don't know before we execute the program that how many times the program is going to repeat or the particular operation is going to repeat, but we know the condition. When that condition is met, okay, either being true or false, then the program needs to stop repeating that particular operation. So here, what it means is that the user connectivity, that is, you will continue to show the main menu after the execution of any kind of sub-functionality until the user selects option 3. Now, we don't know that whether the user is going to select option 3 in the very first execution of the program. That is, the very first time you show the menu, the user might select option 3, and then the program connection will be terminated. Or in the second iteration of the program execution, that is the second time you're showing the main menu, the user selects or gives the input of option 3 and you terminate the connection. Or they do it in the third step, fourth step, fifth step, 10th step, 100th step. You don't know that, right? So you don't know how many times you have to repeat the operation, which is to keep on showing the main menu to the user and allow them to continue to interact with the program itself. But what you do know is that the point of time or the condition when you do have to stop the program is when the user selects option 3. Right? So that is something that you have to keep in mind, that when you have to repeat based on the truth or the false outcome of a certain condition, and you don't know necessarily how many steps it will take to get to that condition, right? Then you would want to code that looping operation or that repetition operation using while loop, right? So if you do something along those lines, then here in this particular case, this is just an example, right? But let's say while, and then we can say option is equals 3, and then we can flip this operation using the logical NOT operator. So what this does is that, remember, all these conditions, these are all logical conditions. So whenever I say logical condition, that means the evaluation of the condition is going to be either true or false. So here what is happening is that it is checking whether the value inside the variable called option is the same as the value 3. So this is basically known as the equality operator, right? And then what this logical operator is doing, this is called the logical NOT operator, is that it flips the output of this particular operation. Okay, so that essentially means that if the option is 3, so that means if this highlighted portion evaluates to true, then this operator will make that false. Okay, and if the overall condition of the while loop, this is the overall condition, which is wrapped within these external first brackets. If the overall condition is false, then whatever the body of the while loop is, right, we do not execute that. So that means we will only execute the body of the while loop when the overall condition of the while loop evaluates to true. So that means, let's say in the first iteration, the user selects the option value of 1. So then we evaluate, is 1 equals 3? Then the answer to that is no, it's false, right? 1 is not equals 3. And then we flip that bit, right? So this is only going to change false to true and true to false. So that means if 1 is not equals 3, so this is false. And then that will be flipped by this operator. the logical not operator, and that the overall condition of the while loop will be true. So that means we go inside the body of the while loop and then we execute it. Okay. If the user enters the value 2, is 2 equals 3? False. And then we have the logical not on the false, which makes the overall condition true. Right? So that will continue to execute the operations here. Similarly, here, in this particular example, if we want to code this as a while loop, let's say, and of course, please keep in mind that you will have to have a loop control variable here as well, which will track the value of the option, right? It will continue to update the value of the option or something along those lines if that use case scenario allows or you require that use case scenario to be implemented. So for example, while in this particular case, we have two conditions here, right? We have a condition where until you reach the value 0, or the maximum length of the list is reached. So here you will need two loop control variables. First, to track whether the value that you are currently printing, if that is equals to 0 or not, or the size of the list or the current iteration of the loop is equal to the max length. So here you would do something along the lines of if value equals 0, right? So if this is true, and then we have to flip this bit, right? Because if this is true, then we want to exit it. So that means the overall condition has to be false, right? So if this is true, or, so we need the logical or operator here, okay? And then the logical or operator will be combined with if the current iteration of the loop, so that means we need a loop control variable, which will track how many times you have already repeated this process. And if that is basically less than or equal to the length of the list, which we can find using the inbuilt operator or the inbuilt function called length. Okay. So if either one of these is true, so that means the value that you are printing is not equals to 0. So we will flip this bit here. So we'll put stuff here, and then we will put not equals to here. Okay. And typically you use these double pipe operators as a representation, as a pseudocode representation of the logical or operation. So if either one of these is true, then you will execute the body of the loop. And inside the body of the loop, you got to make sure that you increase the value of the loop control variable by 1 units in every iteration. So that means before you execute the while loop, you have to assign the loop control variable to an initial value. And let's say that initial value is 0 itself, right? So if your list is basically going from index of 0 to 9, which is a total of 10, so that means this value in the first iteration, it will check what is the value. And then you can also assign an initial value to this value variable. And you can assign that to, let's say, some sort of a -1. Okay, some initial variable. Okay. So here, when you come here in the first iteration of this loop, this operation will be checked. So it will check is -1 equals 0. So that is false. So if you flip the bit, this operation or this thing becomes true. Now, the fun part about OR conditions is that if either of the conditions, or if any of the condition in the total condition, which is combined using a logical OR operator, is true, then the overall operation is true, or the overall condition is true. So what I mean by that is, let's say you have multiple conditions, right? So you have, let's say, A or B or C or D, right? So if you have something like this, and let's say if B is true, so that means the value of B is 1, okay, logical 1, then you don't have to care whether C is true or false, whether D is true or false anymore, because once you hit a true value in a combination of logical conditions that is combined using only logical OR operation, then based on the truth table, of the logical OR gate, the overall condition, that is the combined condition of A, B, C, and D, will evaluate to true if any one of these is true. So if I get this value or this whole expression as true, then I don't care if this is true or false, because the overall condition of the while loop is actually true. And then I will go inside of this, and then we can update two things here. We can update the value and we can update the loop control variable, and the value will be whatever the list value is at the index that is given by the loop control variable, right? So for the first step, the loop control variable is 0. So this is going to print list index 0, and that will be the value here. And then you can print it, and that will be the updated value. So let's say here, the first value is, let's say, something along the lines of 2. Okay, so it will come here and it will check this, and then it will continue to print this particular operation. It will take the new value, and when it goes back to the loop, in order to repeat the step, if 2 is equals 0, that is false. If you flip it, it becomes true, right? And then you go to the next condition, and then you continue these operations. Now, there is going to be a singular problem here in the sense that if, let's say, there are 10 values in this particular list, okay? And what happens when you reach the last index of the list, and after that there is no further input, right? There's no further input that is given. So that means if you have reached the point where you are in the very last index of this list, you cannot go over the bounds of the memory that is allocated for the list, right? So that means if there are 0 to 9 index, if you try to access the 10th index, it doesn't exist in the computer memory to begin with. So this will cause essentially a problem at that point of time, because if we assume a scenario where, let's say, none of the values in the list out of the 10 values that are present in the list is a 0, then this will always give you true. And if the logic of the logical OR operator states that if any one of the condition is true, the overall condition is true, then on the 9th index, that is after the 9th index has passed, it will go out of bounds, essentially, because this will always remain true as long as the value that you're printing is not 0. So that will create a problem. So then what you want to do is this will result in an error at that point of time, because this will essentially, in the use case scenario where the value 0 is not present in the 10 numbers of the list, then this condition will always evaluate to true, this whole condition with the logical NOT operator here. And as a result of that, you would have a problem, because you will go over the bounds or out of bounds of the memory allocation for the particular list. So how this needs to be modified in a situation like that is that instead of using logical OR operation, we will essentially have to replace this with the logical AND operation, such that it forces us to check and make sure that the conditions that are combined using the logical AND, both of them are true for the entire while condition to be true. So what I mean by that is that essentially what you have to do here is, in order to make sure that we force the condition check and make sure that we don't go out of bounds here, which is basically done by this particular condition here, instead of saying A or B or C or D, we do A and B and C and D. So based on the truth table of the logical AND operations, what that states is that all of the involved conditions needs to be true for the entire condition to be true. So now if we replace this with AND, so that means this has to be true and this has to be true, only then the whole while thing will be true. And then we will go inside the body of the while loop, and now we will execute. So now if you revisit the previous condition that we were discussing, that what if none of the values inside the 10 values of this particular list is 0, then this condition will always remain true, right? However, because this is an AND operation, we will have to check the other condition as well and make sure that is also true for the whole thing to be true. So eventually what will happen is that after every iteration, the value of the loop control variable will be incremented by 1. So that means after the first iteration, before this check happens again, this loop control variable will be incremented to a value of 1. That is 0 plus 1 is 1. In the second iteration, it will become 1 plus 1, 2, 2 plus 1, 3, and will continue to do so until it reaches a point where the value becomes 10. Right? So it will continue after the 9th iteration, which is the 10th value of the list. The value of the loop control variable at the end of the execution of this while loop will become 10. So when it comes back to check the condition again, and let's say 0 has still not been found, so this will remain true, right? Because if value is not equals to 0, this will be essentially false. And if you flip that, then that will be true. But if the value of the loop control variable now is 10, and let's say if the length of the list is, let's say, less than that, essentially it will come to 11, okay? So if this is 11, and if we ask ourselves, is 11 less than equals to, let's say, if this is 10, then this will become false. And as a result of that, if you have even a single false value in a combination of conditions, logical conditions, which is combined using the logical AND operator, then the overall output of the condition is false, right? So that means true and false is false. This will only be true when all of the conditions combined using AND is true, right? And then it will stop the execution of the body. So it will not enter the while loop body anymore, and it will stop at that point of time, right? So that kind of ensures that in this particular scenario, we do not go out of bounds, right? So the two ways essentially to summarize on how we can develop loop is, of course, first we have a for loop, okay? And in a for loop, you essentially know beforehand how many times to repeat, okay? And in a while loop, you do not know how many times to repeat, but you have an idea of the condition, which, as long as the condition remains true, you repeat the operation. Okay. So essentially what we are saying or talking about in a more plain, simple word is that you combine a condition with the while loop, and as long as that condition is true, you continue to repeat those operations. The moment that condition becomes false, you don't execute the while loop, right? So there has to be something that tracks the operation in a while loop as well, okay? And you got to update that loop control variable in every iteration, because if you do not change the state of the operations, then no matter how many times you are implementing it, the condition will still remain as the very first step when you are executing the while loop, okay? So that can result in errors like an infinite loop. This is one of the common problems that happens during beginners, that when they forget to update the loop control variables, like we did update LCV here, right? So let's say we never, after assigning this loop control variable to 0 within this body, we never write this statement. So that means the value of the loop control variable never updates to 1, 2, 3, 4. And this condition is always going to be 0 less than equals to the length of the list, which will be infinitely true. So it will never stop. It will always continue. So unless you hit a value 0, which, let's say, out of the 10 values, if you do not hit 0, then you will get an out of bound error essentially. So you got to keep in mind that it's not just the condition that you develop for a while loop. You have to keep an idea that you update the LCV. So make sure to update the loop control variable, whatever is keeping a track of how many times you're repeating and how that corresponds to the state of the condition, right? you make sure that you update that particular variable or set of variables that is helping you design the loop. Another interesting thing is that you can code any for loop using a while loop. That is something that you need to keep in mind. And there is a variation of a while loop, which is seldom used because, again, you can do that variation using the typical while loop itself, that is known as a do while loop. Okay, so the do while loop is basically saying that whatever the logic of the while loop body is, you do that for the first execution without checking the while loop condition. And after the first condition, from the second iteration onwards, you keep checking the condition of the while loop that you have specified. And if and only if the condition is true, do you repeat the operations after that, right? But again, you don't have to worry about this too much. If you want to check it out, you can check it out on your own time. Just a simple Google search will tell you what the logic of the implementation is. But the fun part is, regardless whether it is a do while loop or a for loop, you can, at the end of the day, as long as you see through the logic of what you're trying to implement, you should be able to implement that using a while loop, right? But generally, if we know beforehand what we are doing, we generally go with for loops. And if we do not know how many times we want to repeat, but on all we have is basically the support of a condition, such that as long as that condition remains true, you will continue to repeat and keep a track of how many times you're repeating it, then you do that using the while loop, right? So that is basically the different programming constructs that we will be encountering in this particular program. Next, the cybersecurity concepts that are involved in this program. Now, we have already discussed this in class. If you're new to this, then you can check this out again. The first thing is the usage of the bcrypt library, which is our slow hash function module that we'll be utilizing in order to implement our program. Make sure that you understand on a high level, at least, how the bcrypt library works. So this is basically the implementation of a modified version of the blowfish cipher, but turned in like modified to act as a hash function, right? And then you need to know how digital authentication works. So we have already discussed this in class as well, but you can check it out online if you are unfamiliar with it. And then some of the basic and derived security requirements as established in the NIST Special Publication 800-171 document, which talks about the security requirements that are necessary to be implemented whenever you're trying to implement a digital password authentication scheme, right? So those are some of the basic cybersecurity concepts that are involved in this program, already discussed in class, but this is something that you should be aware of if you are working with this program, all right? I have left a few Easter eggs in this program. I don't know if that is the right word that we should be using here, but essentially what I have done is I have intentionally implemented this program in a certain way that there are certain loopholes which doesn't abide by the basic and derived, either within the basic or in the derived security requirements for implementing digital password authentication scheme. So your job would be to figure that out and then fix it in the program, right? So that will give you a good confidence boost with respect to not just applying the cybersecurity concepts that you should be familiar with, but also playing around with the program that we are going to do. Okay, so without further delay, let us jump into Visual Studio Code and go forward with our implementation. All right, so hopefully everything is working smooth in terms of recording. It's always a concern when we are doing all of this. The nightmare being we record everything and then we see the recording never happened or it did not point to the right window. Anyways, so here is my Visual Studio Code setup. So what I have done here is inside my root directory, which I had created for the first program, that was cybersecurity fundamentals that you see here, I have created another subdirectory and I've called it password storage. Okay. And then inside of password storage, I have created a file called password_storage.py. And this is the empty file that I am working with right now. Okay. And we are going to basically develop our code here. So the first step that you have to keep in mind, or not keep in mind, but you have to implement, is basically you will have to install the bcrypt library, right? So the first thing that we need, or what we say in technical terms, okay, is we need to import the bcrypt library for this program, right? So the way you want to install any kind of external Python packages is by using the pip manager, right? The Python program manager, which is known as pip. So then we use pip install, and then you write the name of the library that you are trying to download and associate with this particular file, right? So here I have already installed this, so it will not install it again for me. But this is the first thing, or the first step that you will execute in order to install or set up your environment, is you will run this command that you see in the terminal right now, which is pip install bcrypt, right? So again, since I have already installed it, it tells me that requirement is already satisfied. For you, it will go through the downloading process. It will be pretty quick. It's not that big of a library, but it will first install or download the bcrypt library to your working directory, such that we can essentially import that library within our program, right? So essentially we can call the different methods. So think of this like a separate file altogether. And inside that file, we have a bunch of functions that has been written, all the mathematical stuff that is involved for performing hash, generating salt. So all those are written as various functions that we will be calling from this particular file where we will be implementing our program, right? So the first step, in order to import that, we will use the import syntax, and then we will specify the name of the library that, or the module that we are trying to import in this program. And the module that we are trying to import in this program is essentially bcrypt, right? So that takes care of it. The next thing is we will have to map out the logic of the program and then how we want to implement it. Now, of course, as we have already discussed in our theoretical overview that we did a while back, well, not a while back, but a few minutes back, is basically there will be a menu. It will show three different options. So the first one will be for registration. The second one will be for authentication. And the third option doesn't have any functionality associated with it, but we can just say that exit the program is what it will do. Okay. And we will essentially wrap this entire menu, okay, inside, let's say, a main function, which will be like the starting point of execution of our entire function. Okay. And this will wrap all of these different options that we show to the user. And then separately, we will write one function for option one, and we will write one function for option two. And we don't need any function for option three because it will just be a very simple exit statement, right? And inside this main statement, this menu will be further wrapped by a while loop. So a while loop will wrap all of these menus. So until and unless the user explicitly picks option three, this menu will continue to repeat after the execution of, let's say, option one or option two. So as long as the user kind of, goes between option one and option two, after the execution of these two functions, so let's say we are going to write one function for option one, one function for option two, it will come back, the program will come back and display this menu again and again and again till the user hits option three, and we will execute something, right? So in totality, then we have three functions. The first one is the main function, which is the starting point of our program. The second function is going to be one for registration, the logic of registration. And the third function will be for the logic of authentication. The reason why I'm not writing this as a function is because this is going to be a very straightforward singular statement, which will just stop the execution of the while loop, and it will terminate the connectivity with the program itself, right? So that is basically the roadmap of how we want to implement it. So let us go ahead and follow the same procedure that we did in the Virginia cipher, where we write down the declaration of our different functions. So we'll start off with the register username. So again, remember the syntax for declaring a function in Python starts with a def, stands for define, okay? And then we give it a function name. So let's say if you want to register a user, you would just say register user, okay? And then the first brackets indicate that this register user is a function name. It's not a variable or anything else, or a list or something like that. And then inside these first brackets is where you can provide the input parameter, that is the input that is being received by the function. So what inputs will be received during the registration process? So the registration process will have the same input as that of the authentication process, at least for the sake of this particular use case scenario. So we will be receiving the username, and we will be receiving a password from the user, right? And then we will give a colon, that is a part of the syntax of our function definition. And here we can either have a return statement or not. So if we do not have a return statement, we'll just say pass. It will not do anything. So for now, we are keeping this as a placeholder. We will replace this with the actual logic of the program when we get to this point, right? So we will decide whether this function is supposed to return anything back to where it is being executed, or it should just stop the execution here, which typically it will stop the execution here. Then we need the second function. So I will do def, and this will be for authenticate user. So we will just say authenticate user. Again, the input is going to be the same. So I will just copy it from here, and I will just paste this. So it is going to take two inputs, one which will be stored inside a variable called username once it is received. Second will be password. And then we will give a colon, which is a part of the index syntax. And here we'll just write a pass statement. So it will not do anything and not throw any errors right now, even though we have an incomplete function body. You can also, instead of just writing pass, you can just write an empty return statement, which essentially says that it doesn't return anything from this function. So that will be a good placeholder. Next that we need, the next function that we need, as we discussed, was the main menu function. So we are going to write def main. Okay. And here also we will just say pass for the time being, right? And then we will figure out what to do with the logic of each of these functions, right? So what do we want to do? So as we discussed, this main function is the starting point of the execution of our program. So everything that is inside this function will be executed first. So that means giving a prompt to the user, giving the menu option, which is wrapped in the while loop, and then calling these other two functions depending on which option the user selects. So if one is selected, then we will call this register user function. If two is selected, we will call this authenticate user function. If three is selected, we will essentially stop the program, right? So the first thing that we would want to do here, we will remove this placeholder now. We don't need this, is we will give a prompt to the user, right? Like a welcome message that we want to provide to the user. So here we can say something along the lines of mock digital password storage and authentication demo. Something. It doesn't matter what you call it here, but we can give it here, right? And this \n is an escape sequence, right? And what it does is that once this message is printed, it will essentially put a new line. But I think, if I'm not wrong, print essentially comes with that new line character, so it will automatically render a new line, right? Next thing is we need to set up the menu. Okay, so here we will keep some documentation. Here is give a welcome prompt. All right, and then here we will say start a infinite while loop. So the reason why we want to start an infinite while loop is that we are, instead of connecting, or how we discussed is that when the condition of the while loop is false, it stops the execution of the body of the while loop. But instead of setting up our while loop in that particular way, we are creating a separate option altogether. And then if that option is selected, then we are going to stop this while loop, right? So that is why we want to create an infinite while loop. And the idea of an infinite while loop is that essentially what it means is that the condition of the while loop is always true, and there is no tracking or update of state after the execution of every repetition of the while loop. So how would you want to implement something like that? So you can implement something like that by using, first of all, the while keyword, which is the syntax for starting a while loop. And then instead of writing a condition here, right, and checking that condition that, oh, is this condition greater than this? Is this condition equals this? Or is this condition less than this? Or any of the comparison operators that you can use. We just want this to be true. And we know for a fact that if we just write the value true like this, which is a reserved keyword again, indicating that this is a Boolean output for true, then this is going to be an infinitely true while, because essentially true is always true. So instead of evaluating, we are just giving the final output of the condition, and we are kind of pre-coding that as true. So that means the while condition is always true. And as a result of that, whatever this body of this while loop is, it will execute infinitely unless something breaks out of or helps us breaks out of that particular loop. And that unless something helps us break out of that loop will be when the user interacts with the menu that we are going to provide them with, and they're going to select this particular option. And as a result of that, we are going to execute a line of code that will help us break out of this infinite loop. Okay, so again, we have a colon that is a part of the syntax, and this will bring us to the body of our while, right? So once we get inside the body of the while loop, we are going to essentially provide the menu options. Okay, and in order to do that, let's say we use again our print statement, and we will write it as a string inside of the print statement. This is what will be displayed to the users. So again, let's use the \n escape character, which stands for new line. All it does is whenever this statement will be rendered on the terminal, it will first put a new line, separate itself with whatever the previous message was on the terminal. So it creates a nice separation. And that's it. That's all this escape sequence does, right? So here we will say enter one. Or let's put it this way: one register, right? And here we can give a little bit of a more concrete message. Input one. Okay. And we will copy this line, and we will repeat this 2 more times because we have 2 more menu options. Okay. So here, and we will remove these guys here so it doesn't look too spread out. Okay. So here we will say 2 and authenticate, and we will say input 2. And here we will say input 3. And again, we will remove this. We'll change this to 3. And here we will say exit the program. So this is basically the termination criteria of this infinite while loop, that if the user selects 3, then we will break out of this situation. Okay. So once we have given that prompt, the very next step, the user will try to provide us with the input itself. So again, as we have discussed in the logical description, we are going to use the inbuilt function called input that allows us to give a prompt and get the response for that prompt. So here we can say something along the lines of choose your option. And here again, to make it more concrete, we can say 1, 2, or 3. Right? So it kind of becomes redundant if we do this, but anyways, we can keep it for like this, right? Okay, so we remove all of these stuff. And then once the user provides an input, this input has to be stored inside a variable. So we will use the assignment operator, that is whatever the input is provided by the user here, take that value and assign it to a variable, and let us call that choice. Okay, so we will store that value inside this variable choice. Now, what needs to be done? Well, we need to run a decision-making statement here, right? Or a decision-making programming construct. And the whole idea of the decision-making construct is if choice is 1, call the function for register, let it do its job. If choice is 2, get the user inputs again for username and password, and then call the function for authentication. If choice is 3, then exit the program. So this is basically a branching statement, right? Because we have to see what the outcome of a specific operation is, and then whether that is this or that. Based on that, we have to execute certain logic. Okay, so essentially, again, and we will continue to be inside the while loop here, so we will not get out of the while loop. So but here we will like right here, like check the input option and execute the relevant code. All right, perfect. All right, so in order to write decision-making statements, we need to make use of if-else. So we will start with the if keyword, which is the syntax. You will take the variable where the user input is saved, and we will compare that, very simple, with the value of 1, right? We'll write that as a string because we have not guaranteed that is supposed to be a numerical value. So if this is true, then what do we want to do if this is essentially true? So here, we first need to get 2 inputs before we can call the function, which will be responsible for performing registration, that we have already written a declaration for, right? But we have not written the body, essentially. So here, what we are going to do is we are again going to use our input function, and we are going to prompt the user to get the input. We will say, enter your user name, okay? And we can give some space here to make it look a little bit pretty. And then we have to assign this. All right. And what will we assign this to? Let's say we just store it in a variable called username. All right. And we are going to do the same thing for our second input, which is going to be the password. So we'll just copy this guy and we will change the appropriate variable name. So here we will just say password. And this will remain the same, but instead of saying enter your username, here we will say enter your password. Right? So that's take care of this. And now we have to call the function that will perform. So we'll say call the function that will perform the user registration. Okay. So in order to do that, in order to call a particular function, all we have to do is take the function name, okay, and then put the first brackets to indicate that that is a function name, and take the variables that needs to be sent or passed to the function. So this will be username and password. Okay, so that takes care of our choice 1. So the next thing is to do the next couple of choices. So the next choice will be else if. Remember, it's not just if else, we still have to check one more condition. So we have else if. So else if is written in Python using this keyword elif, right? So that means if this is not true, then check this. And if that is not true, then do something else, right? And we will see what that something else is in a short while. So here we will again check the second thing. If choice is equals to, then what do we do, right? Again, this is for authentication. So essentially, all of this will remain the same, except for instead of calling registration, we are going to call authentication. So I'm going to copy these 3 lines of code, come here, paste it, okay? And then here, instead of calling register user, I will call authenticate user. All right, and I will pass the password along. Let's just double check that we have not made any kind of errors here. So the choice is 2, username input same, password input same. And then instead of calling register user, we are calling authenticate user, and to it, we are passing the inputs that are stored inside the variables username and password. Remember one thing, that this username password variable, even though it is the same as this username password variable, but they are not the same in reality, even though they have the same names, they are not stored in the same memory location, wherever that memory location is. So this is a different variable. This is a different variable. This is a different variable. Okay, this is not the same variable as this, even though they have the same name. So that is something that you have to keep in mind, that they are present in different locations in the memory altogether. Okay. All right. So that takes care of our second option. Now, if the second option is not true, then we have to check the third option. So we will do elif choice equals 3. And if that is true, then we have to break out of this particular loop. So to break out of this, just write break. Okay, and this will break out of not just this, but it will break us out of the entire while loop as well. And if we break out of the while loop, there is nothing else in this main function. So it will essentially terminate the program, right? You can also write exit in case instead of break here. You can do this in many different ways, how you want to do it. This is just one of the ways. You can just think logically if there are other ways in which you can design and implement this, right? So that is up to you. Now, this is all the three options that we have. But what if we cannot guarantee that user will not, or by mistake or intentionally, enter an input which is not 1, 2, or 3? What if the user enters ABC? Or what if the user enters, let's say, 99? We do not have currently any kind of programming logic that is going to provide a protection against the input of a wrong or corrupt menu option. So what we do for that is we complete this else if chain, okay, by writing a final else, which will be basically the default condition. That is, if neither of the choices are 1, 2, or 3, then what you want to do is you want to say a prompt to the user, which will be something along the lines of invalid menu option. Please input either 1, 2, or 3. And that's it. Remember, don't put a break here. You don't want to break out of the program, because once this happens, it will go back to the while loop. The while loop is still true, and it will repeat this whole process again, and then the user can interact with the program. Okay. So that takes care of this particular main function. And here I will just write a placeholder that set to main. And we will come back to this at the very end. Okay. So let us go ahead and work with this first function here, which is to register the user, right? So we will remove this placeholder value. We do not need this anymore, and we will start working on this. So once this function receives the username and password that is given as an input by the user, what is it that we need to do? Of course, as we saw in the logical discussion when we were looking at the slides, that we have to create a salt. Okay, so the salt has to be generated during the time of the registration. And then we have to take the password that is given, we need to create a hash, and then we need to store the hash, right, along with the user ID, right? And we need to store this inside, for now, we will do a file.txt, and we will keep it there. So that's the whole idea that we have to implement within this particular function logic, right? That is, generate a salt, combine that with the plain text password, run it through the hash algorithm, and then inside a file, we will store the salt, the hashed password, and the user ID for that particular user, right? So that is basically what the registration logic is all about, and that is what we do. So we will do the first step here when we will say generate the salt, right? So in order to generate the salt, we will use the methods that is present inside this particular module, the bcrypt library. Okay, so think of this as basically a file, right? Just like we are writing this file, and inside this file we have different functions. Similarly, the bcrypt module is also like a file that we have externally connected with our particular program. And inside that particular file, they have various functions that are written there. So using after the statement, once we have written the statement, which is to import this entire module, then we can essentially use the name of this module followed by the dot operator, which is basically a singular dot, and then write the name. So what I'm trying to say here is, let's say we create this file as a module. So the name of the module is going to be password underscore storage, right? So then in a separate file, let's say in a different program, you can do import password underscore storage. Okay, you can do that. And once you have written that, then wherever you want to, let's say, use register user, then you can do password storage. So you will take the name of the module, which is basically the name of your file, and use the dot operator. And then you can call register underscore user, right? And then this is happening in a separate file. This discussion is for a separate file, right? So just to make you understand what this import bcrypt is trying to do. So the same is with bcrypt. We used pip install bcrypt. We downloaded that file from wherever the package manager was, right, for Pythons. And now we want to use the different functions which is present inside bcrypt in order to perform certain operation here, instead of writing those codes from scratch by ourselves in every file, right? So essentially, in order to generate the salt, we are going to use the bcrypt module. So bcrypt module. Inside of this, we have a function called gensalt, which is basically generates a pseudo-random number as a salt. And we will assign or store this value inside, let's say, a variable, and we will call that as salt. Okay. The next step we have to perform is basically we have to hash the password that is currently present inside of this variable, which is local to this particular function, and take this salt and then run it through the hash function, which is again present inside this bcrypt module. And we have to store that inside, let's say, a variable here once the output is returned. So let's say we create a variable and we call that hashed underscore password. And this will be assigned to a value which will be computed by using the bcrypt module. Inside the bcrypt module, you can see here, these are the 4 different types of functions that are available, right? We can do the check password, we can do the generate salt, we can hash the password, and there is other stuff like, the PDF function, which is not necessary in this program. Okay, so here we are just going to say hash password. So that is given by hash pw, and the input to this is basically going to be our password, which is this guy. So you can see that the highlighting for this word just clicked up, essentially, which shows that we are actually using this variable, right? But we need to encode this into a particular encoding value, because remember, these values are in string. So what I mean by that is that the input, let's say if the user gave a password of password 123, which is not the best password again, but this is just for the sake of discussions. The operations here are going to be mathematical, right? Everything has to have a numerical value. So when we were doing Visionaire cipher, we said that for any values between A to Z, the variable goes, we have an ASCII encoding where the value of A starts from 97, then you have 98 for small b, and stuff like that, right? And similarly, if you have a capital A, it has an ASCII encoding of 65, right? So, but the fact is, these are just for Latin numeric alphabets, right? From A to Z, numerical values, 0 to 9, and stuff like that. But you can have much, much, much more characters than that in our languages, right? So there is a encoding format, which is the UTF-8 encoding format, which is used universally for like web browsers, which has the capability to transform and store any string representation in a binary representation, which can range from 1 byte to 4 bytes. And remember, 1 byte is equals to 8 bits, right? So depending on the type of character that we are dealing with, and whatever, it's a variable length storage or encoding structure. So if it is a small value and it can be stored within 8 bits, which is 1 byte, then it will just be 1 byte, right? If it requires up to 32 bits, right? So then it can grow up to 32 bits. So that gives us a little bit of flexibility in terms of converting the number into binary and then storing it without wasting space. Like, because there is another variation of UTF, which is UTF-32. So this is always going to store the values as 4 bytes, right? So that means if you have a character which, when converted, let's say requires 8 bits, then you're wasting the remainder of the 24 bits that you have in that encoding scheme, right? So UTF-8 in that sense is a little bit more efficient than the UTF-32 bit, right? So here we will take that password, which is currently in string, and then we will convert that to numerical value using the UTF-8 encoding. So what we want to do there is call on the inbuilt function called encode, and the input parameter to that is to specify what encoding scheme that we are going to be using. So we are going to be using the UTF-8 encoding scheme. I think this is not in capital, it should be in small letter, but we will check if we get an error here. And then the other input for performing hash is basically the salt that we have generated here in line 22. So hopefully I have not made any kind of typing errors anywhere. Okay. Now, once the hash password is generated, the logic was to take this, to take this, and to take this, these three things, username, salt, and hash password, and to store it in a file somewhere here. So this will require us to essentially create a file and then give it a name, create a connection of this program with that particular file, and then use what we call as the file writer to send the information that we have already generated and store it back, okay, into that particular file. So the way we do file input output using Python is using the file writer. Okay, there are many ways, but the one that we are going to be using here is basically the file writer. So first I will write the sentence down, so it will be a little bit easier to explain what we are doing here. So with open, so this is going to, you can see in the suggestions that has popped open, this is going to open a stream connection between the file name, specify the mode in which we are performing the operation, that is whether we are writing on the file, reading from the file, appending information to the file, etc. So this is basically going to create a connection between a file and specify the mode of operation that we are going to be performing on the file. That is, either we are going to read or write, etc. Okay. So the first input parameter to this open connection is basically the file. So here I will say users.txt. Now, this file, since I have not given any kind of file path information, it will be created in the root directory. So the root directory for the password underscore storage.py is basically this password underscore storage. So if this file does not exist, then this file will be automatically created. So you don't have to create the file, right? So this will take care of the creation of the file if it doesn't exist. The second input to this open is basically the text mode, right? So how are you going to interact with the file? So what I want to do here is I want to open the file in what we call as the append mode. So that means if some data already exists in this file, it's not going to overwrite it. It is going to append to the content, right? So that means, let's say in the first execution of this particular code, the file gets created, and then you have in the first line of the file, okay, you have, let's say, ABC. So when this code will execute again, since the file already exists, it will not be created anymore. But since it is being interacted with in the append mode, in the next line, it will just add, let's say, DEF. So if we had opened this file only using the write mode, which is W, right? Then what would have happened is in the second execution of this line of code, it would have overwritten ABC with DEF. But we want to preserve all the inputs, right? So that is why we are using the append mode, which is given by this character A, right? And now we want to create with file users.txt opened as an append mode, we create a file writer, okay, instance of the file writer, which is indicated by F. And then F will have the associated operations of, let's say, read or write present within it. Okay, so this is very similar to, I will have to explain this a little bit more, but first let us finish the code. So we are going to do f.write, and then inside of this, we are going to neatly format it. So we are going to use the f formatting option for the string formatting. And inside of this, we are going to first dump the username. Once the username is done, we are going to separate it with a comma. And then after that, we are going to dump the hashed password. Okay. But remember, this hash password right now is in the UTF-8 encoding, right? It's converted. We need to convert it back to string. So we will be decoding it like we encoded it. And the input to the decoding, we will provide the UTF-8 formatting again. And the final thing that we need to dump here is basically the salt. So we will take the salt, which is stored inside the variable salt. But again, remember, do not forget to decode because this is a pseudo-random numerical value here. Okay, so we need to decode it. And again, the same thing, we will decode it in UTF-8. And after this, we can give a new line, not here, right here, before we finish the bracket here, we will just provide a new line. Okay, so that it renders a new line, and whenever the next value comes, it will essentially print it in a new line. Now, what is happening here is basically f is an instance of the file writer operation. Okay, so it's something like this. So let's say you create a class. This is just an example of, let's say, students. Okay, and inside this, so I'm just creating something like a blueprint. All right, and inside this, you define a function for GPA. You define a function for I don't know, address, editing your address, etc. We don't need more, but let's say you have defined these functions. Okay, so now this is just a blueprint, right? This is just a schema of a student's class. So now if you instantiate an object of students and name it, let's say S, then what S can do is S can use the dot operator and access the GPA function. So this is exactly what we are doing here, is that once we open this connection here and we instantiate it, here we can see that there's the as syntax keyword F. So this is what we are giving the name to that file writer instance. Okay. So you can name it whatever you want. You can write it as the file writer, you can give it F, you can give it file, really doesn't matter. It's just a name, right? So I can name this as student, I can name this as ABC. If I name it as ABC, then it will become abc.gpa, essentially, right? So write is similar to this GP. So this has already been declared within the file input output operations. It has been declared under that particular schema of what that connection entails, right? What methods are abstracted within it, okay? So F can access write, and then this is basically the function call, and the function call is basically the formatted text that we want to store inside this file called user-txt. Right? And once this is done, we will come outside of this file writer IO. Okay. If this is done, generally, it's kind of suggested that you sometimes do f.close. So you close the connection here. Okay. So that you don't keep that connection open. So I will just leave this as a message here that do not forget, we'll close the connection with the file. Okay. But right now we are not doing anything that large scale that can concern us with this closing operation. Okay. And then to terminate the function doesn't have to return anything, because the return part of the function typically we have already executed through these line 31 and 32, where essentially the goal of this function is to perform these operations and then store the information in this particular file. So all that we will do is, in order to give some kind of a notification to the user, we will just give a prompt back to the user that user registered successfully. Okay, something like this, like an interactive feedback. So that takes care of this particular function. Now, next comes the authentication. Now, the goal of the authentication, if you want to write down the logic, is we will first open connection to the file. So that is basically our file.txt, I believe, right? Then we read the data, store in relevant variable. And when we read the data, we are essentially reading what we have stored on the file. That is the username, the hash password, and then the salt, right? And then, of course, we will perform authentication check, right? So what that means is that we will take this password, we will take the salt that was previously stored during registration, and we will compute using bcrypt whatever the hash is for the input that is given by the user, and then compare that with the stored hash of the password that we have. And then we will give a prompt output of true or false. Okay, that means whether the authentication was successful or whether the authentication was a failure, right? So we will do something along these lines. So the first thing is, of course, we have to read the information back from the file. So that will involve us to, again, use this with keyword and open a connection. And please make sure that you provide the same file name. So we wrote users.txt. Now this time, we don't want to open the connection in an append mode or a write. Our goal here is to read the information from the particular file, right? So here we will just open it in read mode, which is given by R, right? And here we will say as F, the same like we did in line 31. And once we open this, now we have to go through the line, right? So there is no guarantee that only a single user has registered at any given time. You don't know how many users have registered, okay? So you will have to check every line to see that the username that has been given as an input here, if that matches one of the usernames that you have stored in the file or not, right? So for that, you have to run a for loop, okay? And the for loop will have a loop control variable. So this line will keep a track of the information as the reader goes from one line to the next line, right? And it will store that information of that entire line inside this variable called line, okay? So that means if the first line has these three values, which is written as a string, then the entirety of this string separated by comma will be stored inside this variable line as this goes from one line to the next line to the next line to the next line until it has finished all the lines that is present in the particular file. So this will be in f.readLines, okay, which is an inbuilt function, again, available there. So what do you want to do? When we save that information, we save the information separated by comma. And we know as developers that the first part of the comma is the username. The second part of the comma is the hash password. And after the second comma, the third part is basically the sort. So what we would like to do is we would like to strip this whole string that is separated by comma, take these individual aspects and store them in their own relevant variables that we can later use for any type of operations that we want to do. Okay, so let's say we create a new variable, we call it stored username, separate it with a comma. Okay, then we create a new variable and let's call it stored hashed password, separate it with a comma, and then stored salt, and assign to these three, right? This is a shorthand notation of declaring and assigning multiple variables in a singular statement, right? So instead of doing it one at a time, I'm just doing it in a single go because what we are going to do is we are going to use an inbuilt method from string manipulation. And remember, this is a string which is storing that particular line that we are reading at a point of time. And for string manipulation, there is an internal function that is called strip. Okay, so that will strip different parts of that string from each other. And the way that we are going to strip it is by splitting the string, okay, by looking for a comma. Okay, so what this will do is that it will split the string by looking for whenever this character appears. So that means whenever this character appears, it will split it. So it will have 1, 2, 3. And then that stripping of that string will then store the value in corresponding locations. So that means the first one will go to this first one, second one will go to the second one, and third one will be stored in this third one, right? So this is what this will be done in a singular operation, okay? So next, once we have extracted that value from the string, stored it into its relevant variables, we now need to essentially perform some checks. So the first check that we'll perform, if the username exists or not. Before we check the password, we have to verify if the password is actually there or not. So we will do stored username. If that is equals the username that is provided as an input here to the function. If this is true, then what do we want to do? We then want to check if these two matches, right? If the hash password matches or not. So then we are going to write another if statement. We are going to call bcrypt, and we are going to call the hashing function for bcrypt. We are going to take the password that has been provided as an input by the user, encode it to the UTF-8 formatting to convert it into binary. All right. And then we are going to take the stored salt. Remember the salt that was created during the registration process. We are going to encode it back to UTF-8, because remember when we were storing it to the file, we had decoded it from the UTF-8 format. So when we bring it back from the file, when we read it from the file back and store it inside this variable, and we want to use it for hashing purposes, we have to re-encode it back to UTF-8, right? So this, if this is now equals to whatever the stored hash password is, which is encoded into the UTF-8 format. Okay, if this is true, then what do we want to do here? We are going to print that if this is true, that authentication was successful, or whatever message that you want to provide to the user. However, and then we want to return true here. Okay, we don't want to return any value to the function. We're just going to return true back to wherever this function was called. Nothing essentially will happen. It will just continue with the while loop. And however, if this is false, all right, so here else, we don't need to check any other condition. So we don't need else if here. We are just going to say else print. And we will say, let's say invalid password. Okay. And since this is invalid, we will return false from the function. So, you know, if you want to capture that and do something here, then you can essentially use that option. Okay. But at least I have not created any kind of receiving points here when the function is called. I have not assigned it to any variable here. But if you want to do something with it, I have created the point here, and then you can edit your code and then, you know, make a decision whether you want to make use of this. If you do not want to do it, then you don't have to return. Okay. And otherwise, we'll go back to the parent if, which was checking the stored username. And here, we're just going to say print. We don't have to do an else anymore because, well, technically is the else. Username not found. Okay. And then, whoop, where did it go? Here. And then if that is the case, then again, we will return false because, well, the program did not succeed with respect to its execution. All right. So I think that should take care of everything. Again, don't forget to close the file connection. So I will just give a statement here. Don't forget to close the file connection. All right. So let's see. We opened the file in read mode. So no accidental, write operations can be performed into the file. We read the lines of the file one by one until it finishes reading all the lines that are currently present in the file. In every iteration of this for loop, it will store the value inside this line, okay, whatever this is for every line. And then it will strip that line by splitting it using this particular comma character, store the first part of the comma character as this variable, second as this variable, third as this variable. Check if the username is present in the stored file. If it is present, then perform the hash of the input password for authentication by combining it with the stored salt and then comparing it against the stored hash password. And if it is true, then the authentication was successful. You can return true or not. And if that is not true, then the password was not valid, and you can return false. And if you go through all the lines and if the stored username is not equals to the input that has been given by the user for username during authentication, then you can just say username is not found and you can return false, essentially. Okay, so that takes care of it. Now, the last thing, which is set to main here. Now, remember where we said here that if you want to import this file in another different program, and you should be able to use this, right? When do you know that, or how does Python know that you essentially want to just call the individual functions that you have written, or do you want to execute this file, the main logic of this file, which is defined inside main? Okay, so in order to differentiate between the import operation of a file or to execute the file as a standalone program, what we do is we add a line of code here, which looks something like this. If underscore underscore name underscore underscore is equals underscore underscore name underscore underscore, right? Then you are going to execute the main function, which essentially completes the execution of this main. Remember, we have not executed main anywhere. So what this is saying is that if when we run the Python program here, when we say Python and then we give the name, if we use the name of the file itself to run it, okay, then this is going to execute the main function that is written within this particular file, which is basically the overall logic of the program itself, right? However, if the name is not the name of the file when we do Python, then it is not going to execute this main function. So if you want to import this particular file as a module to a different program, okay, and you want to use it just like we used bcrypt here, right? You just want to use register user somewhere else, you want to use authenticate user in some other program, so then you can import it and that will not execute this particular logic. This logic will only be executed when I write python space the name of the file, which in this particular case is password underscore storage. So this is a reserved keyword, this is syntax, okay? And if this is equals to this, then this is executed, okay? So that is what all this is trying to say. All right, so let us go over it real quick to make sure that I don't see any error prompts from Visual Studio Code. I see there is this one location here. Okay, I don't see any errors anywhere. Hopefully, I have not made any typos like I did previously. So then I can just do a clear operation on the terminal, and let us just expand this terminal here. And let's see if our program works. So we are just going to do Python password storage.py. Okay. All right. Maybe we can improve the way we have given this prompt by controlling the spacing and stuff like that. But anyways, that's more of a presentation issue rather than a logical issue, right? So let's say if we pick 3, then this should stop the program. Okay, so that means we have verified that option 3 works. All good. So let's clear this up again and let's run this. And let's say we want to register a user now. So we're going to pick one and it's asking for our username. So let's say we say test user and let's give a password. Please do not choose passwords like this, but okay. And now if you had just noticed, a user.txt file was created. And you can see here the program continues. It has not terminated. So that is also in line with the logic that we have. Let's open this and let's see what is the content inside this file. So you can see here first, we have the username. Then we have the salt here. And please notice, since we are using bcrypt, and as we discussed in class, bcrypt allows us to apply a cost factor to the hash generation. And the cost factor that is being applied here, if you notice just this part, this is the cost factor. So right now the cost factor is around 12, and that slows down the operation. This is the part which is actually slowing down the hash function operations. Okay, this is the hashed password itself. Okay, and this is the salt value here, which is generated. Okay, so essentially that gives a unique flavor, even if the password is the same. All right, so we know this is for certain. So now let's do the second option. So if we do the second option, it will ask for our username. So let's say if we give a wrong username, so let's say if I do random user, and we will give random password. All right, so it says username not found because username doesn't exist here. Program continues. We again give 2. Now we give test user. And let's say we give a wrong password this time. So random password. Okay, so invalid password. So that takes care of this as well. I'm running out of space here. So we will do second option again. This time we will do the correct username and the correct password, which I don't remember. I think this was what I wrote. Yeah. And if we do it, authentication was successful. And now you can press 3 and it will terminate the program, right? So all of the key logic is working. Let's say if you want to add a new user to this. So let's close this file. And let's say we run the program again. And let's say we want to register a new user. And let's say we register test user 2. And we give a password of, let's say, refresh 123 lemon. Okay, so registered successfully, it says. So let us go back and open the user file here. And now we can check here. Okay, the salt is completely different again. We are still using a load factor of 12, which is going to slow down the operations. And then this is our hashed password. This big thing here, okay, combined with it. And you can see it's pretty different from that. What we can try is, let's say we try the same password for a different user. So let's say we want to register a user again. Okay, and we say we give a username of, let's say, John Wick. Okay, and we give the same password like we did for user 1, which I think is 1234. All right, so notice here that even if we are using, so this password here is the same as this password in a plain text format. But you can see what the salt is doing is that the salt, since it is a pseudo-random value, right, it is completely changing the nature in which we are storing this password. All right. And let's say if we register another user with a very minute change in the password. So let's say if we do John Doe, right? And let's say we do password 1, 2, but instead of 3, 4, we just do it to 3. So if we store this, then even now you can see that this is your hash password for password 1, 2, 3, 4. And you can see that you cannot compare it even though the change is very minute, right? It's just a singular character. It completely changes it altogether, right? So yeah, so that was the program essentially for implementing digital user authentication. Again, I have left some things in the program intentionally such that it does not satisfy the overall security requirements of your implementation. So what I want you to do is I want you to identify where that problem is. That is the first self task that you can do. And I want you to fix that problem. Okay. I also want you to think whether you can implement this while loop that we see here and all this if else branches in a different way than what I have done here, whether you can improve the execution there. Right. And yeah, if you have any questions, please do let me know. And please keep an eye out for the new assignment on Moodle. Okay, so I'll see you in class next week and or probably in the next demo video. All right, thank you.